Hi, my name is Isian and this is my partner.
Hello everyone, my name is Chotong and my metric number is 202263.
Today we are going to discuss on the application of superconductor, maglev. Maglev is derived from magnetic levitation and it is a method to use to float an object in the air by using a magnetic field. Maglev has been used in many applications, especially in train transportation system, because it can reduce the friction. Thus, it can reduce the maintenance cost of train transportation. In the theory of maglev, the walls alongside the track of the train was mounted a coils of wire inside it. Thus, as the train passes by, the superconducting magnet in the train will induce a current and making the coils inside the walls become electromagnet. Next, the electromagnets will produce a force to levitate the train. There are two types of maglev technology. The first one is electromagnetic suspension, EMS, and the second one is electrodynamic suspension, EDS. EMS used electromagnet to levitate the train, and the magnet was used to keep the train on the track. Next, in EDS, the rail and the train will exert a repulsive force in the magnetic field to levitate the train. The magnetic field in the train was created by the superconducting electromagnets. However, EDS trains are too slow to levitate before it reaches certain speed, so wheels will be used to support the train before it can levitate. The propulsion of the guideway will exert a force on the train to make it move forward.
I'm going to talk about the magnetic levitation, the lateral guidance, and the propulsion of a maglev train. The magnetic levitation can be explained by Faraday's law. A series of figure-shaped 8 coils are arranged in the guideway, and there are many pairs of superconductor magnets built in the train. The superconductor magnets in the train form a magnetic field which is the same as the bar magnet. According to Faraday's law, the bar magnet moves parallel to the series of 8 figure-shaped coils will induce an EMF on the top and bottom loop of the 8 figure-shaped coils. But the net EMF is zero because the EMF induced on the top loop and the EMF induced on the bottom loop are in opposite directions, so they cancel off each other. Therefore, there is no net EMF and no net current flow through the 8 figure-shaped coils. To make the current flow through the 8 figure-shaped coils, we need to slightly offset the bar magnet to the bottom loop of the 8 figure-shaped coils. So, there is stronger magnetic flux at the bottom loop, and the stronger magnetic flux at the bottom loop will induce higher EMF on the bottom loop. So, there will be net current flow through the 8 figure-shaped coils. Current flows through the 8 figure-shaped coils will create a south pole on the top loop and a north pole on the bottom loop. And then a resultant upward force will be imposed on the superconducting magnet built in the train. And the superconducting magnet will have the upward force to lift the maglev train, and the train will be levitated. Lateral guidance is meant to keep the train in the center of the guideway, and the lateral guidance is achieved by using the restoring force generated by the levitation electromagnet. Now let's proceed to the propulsion. There is also a series of electromagnets powered by an alternative manner placed in the guideway, and the front end and back end of the train is outfitted with North Pole and South Pole magnet respectively. Interaction between the guideway electromagnets and the magnets placed at the front and back end of the train happen while the train is moving. Like poles repel and push the train forward, while opposite poles attract each other and pull the train forward, and this is how propulsion of a maglev train works. Let's dive into the difference between maglev train and conventional train. Maglev train does not have wheels or rails because it's lifted up above the ground, and since it's lifted up above the ground, there is no friction. Also, maglev train has a smaller curved lanes compared to conventional train. Let's look at the benefit of maglev train over conventional train. A maglev train has no risk of derailment since it has no rail. A maglev train also travels faster since it has zero friction. Zero friction brings another benefit, which is Zero problem and zero worries of wear and tear. Since there is no friction, there is no wear and tear in a maglev train, so it can save cost too. Thank you everyone for spending time with us. We hope you enjoy this presentation.